do you want to come up to the front? This one is the one to go with, right? Okay, do a quick kind of like recap of what you discussed, about 3 minutes or something, and then or 5 minutes if you want to go that long, and then your guys's ask right now is to think about, okay, well, if we actually try to implement the solution that he's proposing, what would be the next steps tomorrow to actually make it happen? Like, what would need to happen? What's challenging about the solution that he's proposing, and how could we help get this along the way? Okay, Chase, take it away, and I'll give you a little mic.
Okay, so I'll make this quick. There's kind of four bullet points that we summarized here. Number one is like this taboo around IQ research and enhancement. I think it's kind of silly that we have this, like IQ is obviously important, intelligence is important. There's no great reason why this taboo exists. I don't know if I can really solve that or if any of us can solve it, but I think it's kind of a shame that it exists. Second of all, this is kind of more technical, delivering quantities of large molecules to the brain. This is a technical challenge that someone should really take on. There's some companies working on this right now, but there's a number of promising approaches that could potentially be worked on here. Let's see, next thing, I'm just like reading off bullet points here. I don't know how exciting this is. This crypto-based biobank, those of you who were here yesterday heard me talk about this idea. If you're into crypto and you're interested in collecting data for use in like a medical research project, this is a really interesting one to look into. And then last, clinical trials and low friction regulatory regimes. The obvious one that comes to mind for me here is Prospera. This is probably where we're going to be hosting our clinical trials. Prospera is in Honduras. Basically, we think we can get through clinical trials there in like 1 year, whereas in the US it would take 5 to 10 and cost 10 times as much.
What are the trials on?
For us, it's probably going to be like liver disease or something like that first. And that's it.
Okay, comments, questions? Oh, sorry.
Right. How does a trial about liver disease lead to intelligence enhancement?
Well, see, if we get a treatment for liver disease, we can make money, and then we can fund research into some of these other things.
Is there a lot of transfer between those two?
Yes, because you're showing multiplex editing is actually possible within the body, and no one's done that yet.
Nice.
Questions, comments?
For clinical trials, there usually has to be some sort of indication that you're working towards.
Yeah.
So what kind of brain thing would be an intelligence thing that you would go for as an augmentation?
Once we solve brain delivery, the very first thing we go for is like Alzheimer's or something like that. There's fewer genes involved, so it's like an easier target. It's obviously a huge deal. Like, it would be awesome if we could actually come up with a treatment for Alzheimer's, even if it's only preventative. And then in terms of the actual indication for intelligence, there might not be one. Like, this is part of why we don't necessarily want to do clinical trials in the US. Like, we don't, in my view at least, you want to raise both the floor and the ceiling of the human experience, but the current FEM model only allows for like raising the floor.
Do other jurisdictions allow raising the ceiling?
Yeah, they do. Not necessarily as like an insurance covered medical procedure, but like it's allowed.
Which jurisdictions?
So we've looked into Honduras for this. We still have like a ways to go to like figure out the exact actual frameworks for like intelligence enhancement. You could always frame this as like, okay, someone has a low polygenic score for intelligence, and they're going to struggle at all aspects of life because of this. The genes you edit would be the same, so you could always kind of pass it through that loophole or like that framing, I suppose.
If one edit has issues with off-target effects and that kind of things, right? So when you're doing a gene editing, right, you have off-target effects, you have delivery, which is heterogeneous, all that stuff.
Right.
And then you multiplex that by like multiple, whether it's 2, 4, 10. Like, how do you prevent that from statistically going out of control, and then how do you quality control it?
Yeah, that's a really good question. Basically, it depends a lot on the edit site that you're targeting. So the biggest concern is basically insertion and deletion errors at the edit site. This is like the scariest thing. There's other stuff with complete not like site independent off targets as well, but like indels at the edit sites are probably the most critical. The ease of dealing with this depends a lot on how many edits you're doing, as you suggested. So our basic view is like we start with like these disease targets that don't require that many edits, and then we kind of gradually ramp up as the editor technology improves, and we can go after more.
I probably don't know something. In fact, I'm sure of it. But I don't think getting Alzheimer's has anything to do with how intelligent you are.
That's true. It's a different set of edit targets.
I have two questions.
Yeah.
First one is, Ben gave a similar talk at Hemmingbio a few weeks ago, and then there was also one by Zvi, mostly discussing germline editing for intelligence enhancement, and both of them, I think, in my head, have different AI timelines that you're possibly addressing. This one is more like for really short timelines, while germline editing is more for longer ones, but we still would like to do this. But like, for the taboo topic here in particular, like what's the kind of AI safety pitch here, that you're making? And then the second question is like the question that I want everyone to answer, which is if you were trying to do solving some of the kind of like mechanisms tomorrow, what would you be doing to actually start the clinical trials or the crypto-based biobank, which you already discussed yesterday?
Okay, so for the AI safe, like the AI alignment angle, I mean the obvious angle here is like make alignment researchers smarter, and then kindly ask those smarter alignment researchers to solve the alignment problem. And that's basically the master plan.
And there's a lower orthogonality thesis in those AI alignment researchers.
Say again?
There's a lower orthogonality worry in the AI alignment researchers than in AS.
I mean, basically. Also, I think that like the technical aspects of like we've kind of seen that we can make progress in AI just by like throwing more compute at the problem. You don't necessarily need to understand intelligence to make it. I think so from what I've seen so far, alignment is not quite as amenable to just like throwing more and more compute at it. I hope I'm wrong about that, but it seems like we need more conceptual breakthroughs, which is like more, in my view, more limited by max IQ, of people working on it. And then the second question you asked was, sorry.
What's the number one thing that you'd be interested in doing tomorrow to get these mechanisms to work? To help
So I like the number one thing I'm interested in doing tomorrow is basically like making sure that we have the right cell lines being ordered for our lab for our first experiments. I mean, if you want a higher level answer, I can give that too.
Okay.
But.
Well, maybe one final one. And then.
What's the role of human intelligence in the age of machine intelligence?
In what?
What's the role of human intelligence in the age of machine intelligence? Like even if we can augment human intelligence.
Yeah. So I think like once we get like super intelligence, like via digital minds, I don't think this is all that relevant. I basically view this as like a bridge technology for this transition period to like help us navigate that.
Okay. Thank you. Okay, now we're getting to how to prevent very bad outcomes. Do you want to walk us through the notes? They've done plenty of note taking here.
Right. So we wrote collaboratively through a bunch of things, and here the very bad outcomes. There was like a bad initial description. What we meant is how to prevent field shutdown and technology delays or limitations. Though we did generate a whole slew of concerns as well. So first, some kind of like broad definitions. What are field limiting bad outcomes? And so, there's a whole bunch of different kind of bad outcomes here, like banning specific technologies, halting the entire field. Whoa, sorry. Getting to like unfortunate private or national monopolies over it, surveillance control, and so on, like various different kinds of ways of preventing the advancement. Then we source some examples of this happening in other fields. So for example, nuclear power, there's like really good reasons why it's restricted, but it's just an example of a restricted field. Green tech was slowed down and not exactly banned, but slowed down massively in a bunch of places. And there are parts of green tech that are outright banned. Like we could actually solve a lot of the carbon fixing problem by doing a lot more bioengineering, but like, that's also dangerous in other ways. So gene therapies, notoriously banned. Nanotech got slowed down. Cryonics was slowed down and effectively kind of banned for a while, and so on. So these are a bunch of examples. Even cryptography was banned for a while. In fact, Foresight has a lot of people that fought that war for us and solved it. So there's a lot of examples here of this happening. Then we talked about a few of like different jurisdictions that, in the hope of creating some jurisdictional redundancy. There's of course like the U.S. where most of the neurotech work is happening. Also Australia, Netherlands, Canada, Switzerland. These are all kind of jurisdictions where a lot of neurotech R&D tends to happen. Prospera came up as a good example, like jurisdiction that could allow some of this to happen. There's a lot of kind of charter cities. Then, theoretically, potentially Mars eventually, although the timeline is rather short, and so on. Yeah. Yeah. You unpack the lab and then you get AGI. Oh, man. Then we talked about, how to influence jurisdictions over time to make sure that you get to good outcomes. We also sourced a bunch of examples that, if you kind of scale the industry quickly, then the industry tends to fight for itself. Like, for example, there's lots of good evidence for lots of fields persisting and kind of carving a space for themselves just by existing. So you just do that really quickly, then the field sort of protects itself. Separately from jurisdictions, there's just the process of let's make sure that we don't kind of run out of money in the entire industry. So let's get a bunch of governments and VC and philanthropy to allocate capital towards this. Generate more financial instruments to progress the R&D. Then most of the focus of went into ways of getting the mainstream environment to align. So this goes into kind of propagating values, getting alignment on the messaging and communication, how to coordinate large groups, making sure that doing good balancing of all of the communications that need to happen. Basically effectively good mimetic engineering. Then we talked about kind of problem solving the negative. So make sure, so it's not just about kind of making the field succeed. We have to make sure that the field solves the negatives and make sure the problems and negative use cases are well addressed. There are lots of very big valid concerns, so let's make sure that those are addressed. Then stress the positives. Deliver extremely good positive results early to build confidence, so that it's not if you get a field that where all the initial results are bad. Then that's more likely that the field will get slowed down. Then we kind of thought about some of what would potentially be interesting results. We talked about IP. We talked about all kinds of other getting lots of communities in academia and broader industry to get more involved, and so on. You can see some of the questions here. There were also a few interesting notes around establishing self-modification as a human right. First off, there's been a number of attempts at that in the past, establishing groups of humans that fight for their own rights. Then at that point, it's well, who are you to exclude them? Then we did list a whole bunch of concerns that need to get addressed. This is not at all exhaustive, and there's a lot more. And then some of the mechanisms that have happened in the past that lead to this kind of bad policy creation. Cool. Any questions? Yep.
What about, intelligent? We might say, oh, she's a musical genius, he's a math genius. It's not a single-dimensional thing. I'm a little concerned about using it too broadly.
Yeah, I think we all agree. Yep. Yep.
Yeah, so there's I think there's a disconnect between people in this room and outside of this room, right? So
Hi, camera.
but I mean, there are people that would fight you, for instance, about whether or not you want to help deaf people hear, blind people see, whatever. But most people probably...
And these are legit fights that are happening right now.
Right. So most people probably wouldn't, but there's that community. But then when you start to think about changing intelligence, interfacing with the brain, all that sort of stuff, the upside of it is compensating for damage and disease, right? Which again is probably less controversial outside of the room. The people that are pushing the field across not just this, but other communities are thinking about, how do I interface with my computer? How do I get super intelligence? How do I beat the AI? And which is just, maybe they're maybe they're correct and ahead of the world because the world hasn't seen what AI can do. And then like everyone just catches up, or maybe they view that as apparent. And like, so I guess I'm curious if you have thoughts on how do you manage that fundamental conflict between the people that are pushing the field that would develop, the compensatorial, like the things to compensate for damage function, also have like personal agendas and interests which are way ahead of the average person on the street.
I mean, well, and I wouldn't necessarily like just directly like describe way ahead or whatever. Like I think there's no spectrum here. In fact, there's a very large plural environment with lots of different opinions and perspectives, like really massive space with huge disagreements in that space. And there's good, in like the liberal democracies, there's good precedent for establishing rights for the self and for the individual, as long as you're not infringing on the rights of other parties. Where this gets, and so that, for example, is fine for self-modification, right? Like if one person wants to go get tattoos, that's allowed now, right? Like that wasn't necessarily allowed in all societies. In fact, in some societies, it's not. If somebody wants to go and get piercings, somebody wants to wear a certain type of clothing, like we fought pretty hard to like get protections for that. That will extend broadly to some of this. Now, where this gets messy, like really messy, is with children. And you see a bunch of those fights happening right now, where there's all kinds of like questions and fights around should you screen for certain genes in IVF, for example, or should you and that might be preventing specific diseases or damage, or it could be enhancements, right? And so like that's where a lot of that discussion is happening. I think the timelines are such that the children issue is less relevant, and I think we'll likely encounter very high bandwidth BCIs and likely some early uploads before those fights about what do you do with children get fought and decided.
That's optimistic.
Yeah, I did give some spicy timelines at the beginning, so. But I will say that my track record timelines is not that off. All right.
There. What would you do? What would you want people to do tomorrow to kind of get working on this?
Oh yeah, and sorry, like I kind of like dodged the question very elaborately there. In the like, I expressed my broad opinions about like how the world should navigate these kinds of issues, but very concretely, I think the big way to address that is just broad mimetic diffusion, meaning like the earlier part here about kind of propagating a lot of the values and propagating the reasoning and getting people to understand the why is super critical. Like that is like absolutely essential to a bunch of this stuff. And so there are a lot of groups that like are just forging ahead without doing that. But I do think that many of us, Foresight NPL, spend a very large fraction of our time diffusing the memes to everybody to help understand the case for these things.
When do we start the media company?
I think many have been started.
Oh, good. Never mind.
Yeah. No, yeah, they exist now, which is pretty cool. But, in fact, the Marvel movies are extremely pro tech advancement.
True.
There's a lot of stuff there, like nanotech, cryo, BCI, lots of things. So
it's going to be a long time.
that was no accident, by the way. I don't think that was at all an accident.
The right mover.
So yeah, we can get bitten by radioactive spiders.
Yeah. Yeah. So and you had a question about what should we do or something like that?
Yeah, but I guess you said it, like mimetic dispersion.
Yeah, mimetic diffusion. Yeah, and I think like this jurisdictional question I think is very important, and so I think establishing groups that kind of like help protect neurotech rights in a bunch of places seems very important. All right, thanks.
Awesome, thank you. Yeah, I think we're almost, we're nearing the end here now, especially battery life concerning. Okay, last but not least, final one, and then we do the closing. Biohybrids. Do you want to come up here?
The notes are actually
on the towards the bottom.
My phone.
Here, or
It's in one of the cell
A different,
few rows above.
a few rows above. Okay.
It has.
This one?
Yeah, that one.
Okay.
These two can. Yeah.
Let me just move them. Is that okay?
Thank you. Yeah, I love that. Thanks.
So I'll move them to biohabits. Otherwise, we will get confused. And then we have.
Would you like to?
Sure.
Okay. Because our presenter, Max, is not here.
You will do a great job.
Okay.
Yes.
So these are
I'm
some
sure of it.
summary of the.
Microphone.
Go for it.
Okay, so these are some summary of the super fascinating discussion about the biohybrids. In our discussion, we chatted about this paper. It's called "When Bio Meets Technology: Biohybrid Neural Interfaces," and it's written by a researcher who's now working with Max, and it's basically talking about how we have all these electrodes and like these digital implants for BCIs, but what about electro implants, devices that can hold live cultured cells? So that's where Max's biohybrid neuroimplant direction is. So that is the research topic. And in terms of funding, like opportunities and challenges, so it would be really great to just jump in and solve problems for patients with eye issues. And there's like some subtopics that we mentioned. For example, like the colors. It's like vision is so refined. So like it's not so easy to just solve it. But color apparently is a component, but also the distractibility. So like the devices can provide vision sometimes in a way, but you were telling a story about the patient.
Yes, on the biohybrids, like the discussion was around a chip that I guess goes on the surface of your brain, and then neurons that project down into your brain, and they're heavily modified so that they stay alive and connect. And then the discussion was like, well, what can you do with that, today? What are the applications? And it's an interesting thing because it's hard to interface with the brain with electrodes and that sort of thing. You've got something hard going into something squishy. So it solves that problem. But on the other side of it, you don't have full control over where they go. So what does that mean, and what are the kind of utility areas, and how do you do it? So that's we went down. I think that's being decided and figured out in real time. But we went down and talked about that a little bit. The vision stuff was more about optogenetics and just how you interface with the eye, which doesn't use those technologies. In some ways it's simpler because you can get at the eye directly. But then there are also the questions of like, what is vision, which go same questions hold, but more so if you're going directly in the brain, because like, are you interfacing with functional elements or more broadly with pieces of compute, and how does that all work? So I think that's, I don't know if I missed anything.
Yeah, no, that's great. And then also something about the fixation about the eyes. Sometimes when it's implanted for the vision, for the patients, they don't see it like how we see it. It's sort of like they have to move around. So it depends on the patient's ability to fixate as well.
That was a previous technologies around electrical implants. Yeah, so there's the question of like, for all of these things, right, which is being understood in real time of like, what exactly are you connecting to? So for vision, right, vision is a very highly refined sense. So presumably if you're putting an implant, you want it to respect that for it to be useful. And if you do respect that, is it also like something that the patient is going to want to use? And so there was discussion about like what is required to do that, whether you need to be able to get, full vision, or you need to be able to just respect geometries and things like that. And all of this is probably, and we didn't talk about his technologies, but I would suspect that you answer these when you're in people. But same questions, but harder go for the brain when you're, if you have a very high density set of neurons going into the brain, then the question to be determined still, because it's ahead of our current understanding, is, what do you get right? And how do you use that?
And
Do you want to
another,
say a few things about this part here?
oh, the R&D.
Yeah.
Okay. So the challenges related to the R&D, Max shared a little bit, is the immune attacks, of course, and also the graft survival is also super critical, but that's also really hard. Another thing is it's hard to license certain tools because companies who have the tools and can license are so worried about if something goes wrong in the patient's experience. And if just one patient has some issues, then the FDA can come in and just shut down the whole pipeline of this, which they can, of course, start another device, but it'll take 2 years and millions of dollars. So companies are very careful about licensing, which is like a big challenge in the R&D process. Another thing about funding earlier is just, it would be really great to have a cool GPT-4 moment. Like something big for the the BCI field to really thrive. But there are also some plus that's really great for the field, like neurons are not dividing, so I guess there's less concerns for if you implant something and they just go crazy and divide and divide. The brain is also really good at finding meanings if you feed it information. So Max mentioned something about like patients were able to see some vision with the implants with the sound coupled. And when they shut off the vision with just the sound, there was that co-triggering. So something along those lines, but it just shows that the brain is very flexible in building that connections. So lots of hopes in the R&D space as well. And then the last thing is that with electrodes, it does take up space with the wiring, but with cells, and then brain has so little space. So with something that takes up space in the cell with traditional electrodes versus something that's more cell-based, there's also unique advantages.
Cool.
Yeah, there was some discussion around the different ways of getting information in and out of the brain, right? And we talked about optogenetics, which is light, electrodes, and neurons coupled to electrodes. And the short answer is there's no silver bullet, but the neurons coupled with electrodes seem to have certain benefits in terms of longevity of an interface.
Great. Thank you, guys.
Thank you.
I think we have time for like maybe one question or comment.
What's that?
It's
On brand.
bio and machine.
Any other questions, comments? I have one, like, what's the number one thing that you'd incentivize folks to do tomorrow to get more work going on this area?
I would say thinking about, I guess just what we discussed about the media and the Marvel, we discussed about the media, like the Marvel movie, and it got me thinking, because Max was also mentioning, we need like a GPT-4, like a big sensational moment for BCI. Well, he was talking about how, Elon can go as long as he wants to like build the BCIs, but for the field to survive as a whole, we need something that's sensational, like a big splash. So I would say something we can do right away is to just like tap into our imagination and think about what kind of those things could be and kind of build some cultural narratives around it to get people excited or just like be more concrete about what can be achieved.
Great. Okay, final question over there.
On the tool licensing issue, is it that they're tracking it on the IP level or at the company level?
So what happens is like all of this stuff is very highly fragmented. You need a viral vector, you need promoters, you need an effector molecule, et cetera, right? And so invariably you are in licensing from other people, and those people that are out licensing to multiple people, including large pharma. And like large pharma's nightmare is, I may or may not use this thing, right? I license it because I think it could be cool, and then some small company does something crazy and a patient dies or gets super sick, and then FDA will not let you use that tool, right? And they'll view themselves as being more careful and better better equipped to use it, or the person licensing the tool will just want to be super careful because it's, it goes from X billion dollars of potential to zero, right? Basically the way, like, particularly if you're looking at viral vectors and such, if you have a viral vector that is proven in a large population of people in a tissue type, then that is super beneficial for anybody that wants to deliver a gene or an edit or whatever to that tissue type. And before you have that, it's all hypothetical. And, if somebody dies, it evaporates. So that's kind of their concern, and it's sticky. There isn't like an easy way to navigate it.
All right. Thank you so much. Thanks for note taking. I really appreciate it. All right, you guys, we're at the end of it. I know we're 5 minutes over time. I sincerely apologize for that. My German heart is crying. But this is a very tiny workshop of workshops that are usually 2 days long. I guess the whole animation workshop that we're doing in May is going to be 2.5 days long, with much longer breakouts and so forth. But we just want to give you a taste of what kind of new develop, what thinking about speeding up new developments in this field could look like, especially considering that we have a really strong kind of new R&D and crypto expertise here as well. So thank you so much for joining. A few pointers for follow-ups. First and foremost, if you're interested in chatting more with people about this, join the Telegram group. It's across the different events. So it's not just this event, but it's other events in the series too. Many of you are already in there who were here from yesterday as well in the longevity event. If you want to attend more workshops in this mini kind of Path to Progress series, the next one is on nanotechnology tomorrow, which I think is still the most undervalued area. Then we have one on cryptography, security, and AI on Monday, and on space on Tuesday. So if you're interested in that, on the top of the collaboration doc is that link. Then there is the entire cosmos of LabWeek going on as we speak, with a pretty mind-blowing schedule. So this is the schedule for tomorrow. And then, of course, Funding the Commons, the big one, is Saturday and Sunday, which I think many of you would really, really enjoy. And this is kind of it for the next few days or so. If you want to stay in touch, we will be sending out a follow-up email with a few informations about how to stay in touch with Foresight and Protocol Labs. But I just want to highlight that if you want to stay involved with Protocol Labs, here is the directory. So if you only cut yourself short, not follow the follow-up email, this is the directory where many projects kind of in this space exist, and it's a collaboration base for people in this space. With that being said, thank you so much, Protocol Labs, for making this possible. Thank you so much for so much brain power going into this. We can still be here for an hour if you want to hang out and have drinks. There'll be some served over there. Thank you so much for this really fantastic effort. Really, really appreciate it. And hopefully see many of you tomorrow. Thank you.
Thank you.